Hello, everyone, and welcome to Infostrux's very first webinar. My name is Pierre Clich. I am Infostrux's VP of Engineering, and I will be your moderator today. However, today our star speaker will be, Infostrux's own CTO, Milan Mosny. But before handing it over to him, I would invite you to direct all your questions you may have during the speech to the Q&A section at the bottom of your screen in the Zoom window. We will be hosting a lightning round of Q&A questions towards the end of the presentation. I will be creating the questions in the meantime, so it will be your voice when you cannot be heard. Apart from that, we would very much like to thank you to be here. This is our first presentation, of course, so please go easy on us. There may be a few hiccups here and there along the way. We are, figuring that out. So yeah, I think without further ado, I will hand it over to Mr. Milan Mosny.
All right. Well, thanks so much, Pierre, for that very nice introduction. So today, I'd like to talk a little bit about data engineering and focus really on how much work is it and how much effort usually goes into it. And how the webinar is going to be structured is that I'll introduce very quickly data engineering, data analytics, and talk about different aspects of what makes it difficult. And then we'll go through the memory lane, so to speak, and have a look at different approaches that were taken to implement data engineering. We'll be talking about traditional data warehousing, about modern data warehousing, and about the current trends in the data warehousing and how they affect the effort. So what is data analytics? I mean, in my mind, it's all about making data useful. So this is all about putting together reports, dashboards, KPIs, and on the more advanced analytics side, it's about predictive analytics, it's about prescriptive analytics, it's about real-time analytics. What data analytics does to us is that it really allows us to understand our business better. We can therefore make better business decisions, and then we can optimize our business, make it a little bit more efficient, a little bit more productive. Now, in order to do that, what has to happen is that we have to do a bit of data engineering. Now, what is data engineering? Data engineering is really about preparing data for everybody else. So before we start making reports, dashboards, before we start having a look at the data models, before we start creating and training neural networks for prescriptive data analytics, we really have to do a good amount of work to make it all happen. Now, putting it bluntly, really, data engineering is about putting data in one place, and this is perhaps the most important part of it. But then we also have to figure out what is what and document it. It's very difficult to do data analytics on data that's not well understood, and this is the part that does it. Then we have to clean it up. Quite often there is lots of data quality issues in the data, so this is the part that handles that portion of portion of the exercise. And then we have to integrate it and create structures that are ready for analysis. Now, once all of this is done, data analytics becomes much easier, and then things like creating dashboards becomes a matter of maybe a couple of days, if that much. Quite often, if the data is structured properly, data is structured nicely, people can just come in, and the end users, the business users, can create dashboards themselves and have a look at different trends and data dependencies. Now, what's interesting about all this is that the data engineering is the difficult part. Data engineering quite often takes 80% of the whole effort of many typical data analytics projects. Maybe surprising, but that's what it is. And then here is the reason. It's tedious. It's really quite difficult and requires lots of work. Now, very often people don't perceive data engineering as something that's difficult. It seems very natural. It seems very simple. Oh, well, we just have to put together revenue by month or whatever simple data, and it's all done. But really, what is happening is that the devil is in the details. So there are different levels or different aspects that we have to have a look at when doing data engineering properly. First of all, we have to understand the domain. Sounds easier than it is, and quite often for the users, for the business users that already live in the business space, this is natural. This is what they do every single day. But for data engineers, or for people that are trying to put together a data engineering solution, it is really important to go in and understand almost every single small little detail about how the business works, how the business is structured, what's happening, what's not happening. So, for example, it would be quite difficult to put together a data engineering piece in a point of sales domain if one doesn't understand what is the difference between returns, and refunds and voids, when they can happen, when they cannot happen, how they impact the actual cash in the till and the amount of products sold and all that. So this is the first part. It's nowhere near the worst one. The next worst one, or the next level of detail, comes when we start talking about the requirements. So this is where it gets deeper into the weeds. Even a simple statement like a revenue by month can be interpreted in many different ways. Quite often when you talk to a business user and you say revenue by month, it's absolutely clear in their mind what this means. But depending on who are you talking to and what the user has absolutely clear in their minds, this may happen. This may mean many different things. If you are talking to salespeople, revenue is probably booked revenue. If you are talking to your finance people, this is probably related to cash flow or revenue that's collected. If you are talking to delivery people, this is probably a revenue that indicates how much work they're going to do in the next month, and how much product are they going to roughly ship out from the warehouse. And that's just one word, and then the number of variations and combinations on that can go into that one particular word is actually quite large. Same thing with month. I mean, what can be ambiguous about month? Well, again, depending on who we are talking to, this can be month based on the posted date. It can be month based on the invoice date. It can be month based on the book date. It can be month from a fiscal calendar, or it can be month from a regular calendar, or it can be month from a manufacturing calendar if you are in the manufacturing domain. So really understanding the requirements, as with any software project, is paramount, and it's very important to get it done right, and has to go deep into the details. Now, the next part, this is where the tediousness comes in. So not only we have to understand the requirements at the very fine level of detail, we also have to understand the data. And why is this tedious? Well, quite often you have data sources with hundreds and hundreds of tables and thousands of columns. And in order to do this right, we have to understand, perhaps not all of it, but a good portion of it. So the understanding the data means really understanding the questions such as, what does status activated mean? What does the date 9999 -12-31 that we saw in the database mean? What does it mean altogether when the status says activated and the activated date says 9999-12-31? So there is lots of permutations, lots of combinations that have to be analyzed and properly properly comprehended in order to start working with the data. So this is about the details that the data engineering has to go in. The next part, which is perhaps even more important, is the expertise that is required in order to do data engineering properly. So the first part we already talked about. So this is about business domain understanding and deep understanding of requirements. And the second part is also a little bit about what we talked about, which is about understanding the data. But now we are talking about expertise that actually needed to do the solution, to make it happen. So suddenly we have to have expertise in data architecture, and we have to have expertise in data modeling. We have to know how to design the data pipelines properly so that they will work and scale properly, handle large volumes of data, that they will not break, they will fail over and all that. And then we have to actually go and do the work and develop these pipelines to make sure that the data gets moving. We will also need quite often a little bit of regular software development expertise in order to pull the data from exotic sources or maybe in strange formats, from strange APIs and so on. So really the the expertise is quite broad already. Now, in order to make the solution work holistically overall, there is another set of expertises that needs to happen. On the on the infrastructure side, on the lower level of the whole solution, we have to have a very capable database administrators and that are able to optimize the solution properly. We need to understand the infrastructure and operations, or at least have a DevOps, which is quite often even more demanding than the infrastructure and operations may be. Definitely one of the very important parts is data governance. We have to understand the policies under which the data can be used. This is about who can see them, what the data is, where does it live, how it can move through the enterprise, what happens if there are what happens there are sensitive amounts of sensitive parts of data, what exactly are the compliance requirements, everything like that, everything policy related goes under data governance, and it's a very important part of the whole exercise. Then there is security. Enough said. I believe security these days we see in the news about these guys being hacked, that company being hacked, that data set being exposed on the web. This is something we would not like to happen, and security is therefore very important and needs to be and the proper expertise need to be provided in order to make the solution secure. Putting it all together is project management. And again, project management becomes a little bit more interesting in data analytics solution or data engineering solutions, because it does have to put in the expertise. It does have to put in the expertise from many different areas, and then make sure that everybody talks to each other, everybody all the dependencies are captured, everything is done properly the way it needs to be. So that's the expertise required. And it really hopefully shows that data engineering is not a simple exercise. The question is it getting easier? Here are the main approaches that we saw in data engineering, going through different parts. Sorry, that were popular or important during different times. So it all started, well, actually it didn't start it there, but the majority of the data analytics solutions before maybe 2010, before 2000s, were done using traditional data warehousing. The next approach there is modern data warehousing that explores a different way of doing things and expands the capabilities of the traditional data warehousing. And then there are the current trends I'll talk about, and I'll pick one particular one, Snowflake. I mean, we are a Snowflake partner. It's very easy to talk about it, but it's just one of the many possible technologies or approaches that demonstrate the current trends in data analytics. So let's start with data warehousing then. This is how it looks like. And what's happening is that we have the data sitting in the sources. Usually these were databases, perhaps some applications and files. And then the data is loaded into staging area. And what's happening there is that staging area contains tables that whose structure is very similar to the structure of the sources. It definitely does not contain all the data. Quite often it just contains the differences between between what was in the data before the last load and what's there now. So it's a fairly narrow view of the data in the sources. Now, once the data is loaded into the staging area, it's modeled into an enterprise data warehouse. This is usually a fairly normalized structure that reflects how the business works. And then the data is massaged into data marts that prepare the data for analytics. So these are your usual star schemas, maybe a little bit of Snowflake thrown in, so that the reporting and the dashboards can be made easy, and then perhaps some exports that to downstream systems can be generated. Now, if you look at the picture, what you see is quite often this whole this whole traditional data warehousing was done on one single system or one or two major technologies. It used to be the whole thing was Oracle, or the whole thing was SQL Server. And then really the person that, or the team that was working on the traditional warehousing did, from the technical point of view, had to know SQL. They had to know SSIS, and that was about it. Or they had to know Oracle, and they maybe had to know Informatica or some other tools, or some other tool. But it was usually one tool that did it, and then one database, maybe two, that were taking care of the traditional data warehousing. Definitely some issues with traditional data warehousing, and the main one is that each individual piece of data has to be touched upon. It has to be analyzed and understood, it has to be extracted to staging, has to be cleaned, has to be normalized, has to be loaded into data warehouse, dimensionally modeled, loaded into data mart. If you are talking about a data warehouse that has hundreds of tables and then thousands of columns, we need to do all of this 1,000 times to make sure that the solution works properly. And then this is roughly the high-level view of the effort that needs to go into the traditional data warehousing. What you see here is that the major component of the traditional data warehousing is the data pipeline design and development. And this is because of what I just talked about. This is because every single piece of data has to be touched. It has to be taken care of, even from the point of view of staging. Quite often you already have to have staging structures that are exactly the same as the structures that are there, that are in your source systems, and suddenly you are replicating every single column in your data pipelines and the data development, the pipeline development. So that's definitely where most of the effort is coming in. Now, if you look at the expertise column, all of the values there are narrow. Now, what this means is that in order to work in a particular area in the traditional data warehousing, is that the expertise required is fairly narrow. Means we have to understand perhaps one single domain or one or two major data architecture or data modeling approaches. Even in the area where the effort is very high, which is the data pipeline design and development, we need to understand a couple of technologies. Everybody knows them. Everybody can work together, and so from that, at least from that point of view, it's fairly simple and fairly easy. So that's traditional data warehousing, and again, the major trouble there is that the data pipeline design and development effort is very high because we have to touch every single piece of data. Next one up is modern data warehousing, and it does solve some of these problems. So how the modern data warehousing works is depicted on this picture. Now, I understand every time you talk to somebody about modern data warehousing, they'll draw something different. So this is perhaps just one example of how modern data warehousing can work. But there are some important parts that I'd like to talk about. So first of all, the sources are much more broad. We have databases, we have files as we had before, but we also have cloud APIs, we have mobile data, we have IoT sensor data, we have on-premise systems that can send security logs, anything you can imagine the sources may contain. Now, this is possible because of the big data technologies that are now being used by modern data warehousing. We can now afford to really load all the data that we can think of and simply store them in a storage for future use. This was not possible with the traditional data warehousing, where the staging areas were very limited, and only a portion of the data can be done. So modern data warehousing already brings a good amount of new functionality to the table. Now, there is a couple of things that happen to make this possible. One is the big data technologies, meaning that they can handle high volumes of data, high variety of data, and high velocity of the data. One of the important parts is that suddenly we can do ELT as opposed to ETL. What that means is that we can load the data before we transform it, before we touch it. The piece of technology that enables this, or the piece of that enables this, is called schema on load. So, for example, Twitter data. Twitter data is a JSON structure that, when it gets normalized, ends up being about 100 tables out of the single tweet. That doesn't have to happen with modern data warehousing. We can simply keep the data as JSON loaded, and then look at the bits and pieces later on if they become important, if they become desired, but we don't actually have to come up and then start staging them the same way as we would do in the traditional data warehousing. So we're already saving ourselves the work of creating 100 tables to make sure if we ever want to have access to all the Twitter data. This enables data analysis and data science workflows. Suddenly, the data analysts and data scientists don't have to wait for your BI department or for the data engineers to bring the data in all the way through the staging, all the way through the data warehouse, all the way to data marts. They can hit directly the raw area that contains the tweets, or maybe slightly curated area that contains the data that's a little bit more structured and perhaps somewhat cleaned. But the effort required when the data scientist comes to us and says, well, can I see whatever Twitter retweets number? It becomes much smaller. We already have the data, the tools are there, they can handle the unstructured data just fine. The data scientist can just come in and then start working. This impacts also the enterprise data warehouse and data mart areas of the solution. We don't. What this means is that these can be a little bit smaller. We don't have to address every single request we get from data analysts and the data scientists, and we can keep the data in the data warehouse and data mart a little bit narrower. Now, the data warehouses and data marts are still important. They still have to be there in order to provide the usual single source of truth that's properly modeled, properly understood, and making sure that the revenue by month means exactly what it needs to mean, and then the reports and dashboards are running properly. But the work that will have to go in order to enable data exploration in the data science or data analysis sense is not required. So when we look at the benefits of the modern data warehousing, the main ones is that it can do more. It can definitely load different kinds of data. And then one of the more important ones is that there is suddenly no need to model everything. The effort that goes into building the model structured is a little bit lower. Challenges, definitely. This is no longer a single platform. You saw there was many colors, many technologies mentioned on that on that image. It is really becoming a complex systems of many technologies, many areas. That's a little bit more involved in order to and that there is much more effort involved in order to manage it. Another challenge I'd like to point out, it definitely needs stronger data governance than before. The amount of data that's available to the users is just staggering. It doesn't mean that that the policies that maintain it or that are governing it don't have to be written, don't have to be put in place. So without strong data governance, what will happen is that your data lake generally become a data swamp, this bunch of stuff in it that nobody understands what is where anymore. Nobody understands whether we are still compliant with our privacy policies and all that. Generally, this would not be a problem with traditional data warehousing, because everything is modeled, everything is done in proper structures. But in modern data warehousing, this is definitely something that needs to be looked at. So here is our scorecard. The main point I'd like to make here is that the data pipeline design and development went from very high to high. So that's why it's now shown green. And then this is this to me is one of the most important parts of one of the most important contributions that the modern data warehousing brought. The fact that not everything has to be modeled, not everything has to be put into structured formats, and then still we can still deal with high volumes of data of high variety is really the most important benefit there. The data architecture and data modeling go down from medium to about medium low. I mean, these are all very relative, and we can argue about what does this mean, but let's just bear with me, please, for a second. So these parts go down. However, there are parts that there are areas of expertise that go up in terms of effort. So security suddenly becomes a little bit more of a concern because we are not securing a single database or single database system that runs one or two technologies in it, but we are securing a hybrid complex systems of many different parts, many different technologies, each of which has its own security requirements, each of which has its own security approaches, and they all have to work together in order to make the solution secure. Data governance, I already talked about. And then if you look on the expertise side, suddenly the person that works on the data architecture and data modeling that doesn't need to know just I don't know, in Milan and Kimball, but they also need to know how to model data properly on white tables, how to model data properly with structures that require partitioning, how to model data properly on Hadoop, Spark, any of those technologies. Columnar databases, you name it, it's there. Data pipeline design and development becomes a bit of a mess in a sense. Suddenly, again, we have to understand multiple technologies. What quite often happens is that the traditional people that work on SQL stop talking to new people that they are taking care of the big data frameworks. Communications issues are becoming a bit more prevalent, and then definitely the expertise needs to change. It's actually quite wide. The teams become a little bit more broad, so it does bring its own set of problems. Same thing on the database administration, infrastructure, and security and data governance side. These all suddenly become a little bit more involved. They do require a little bit more work from the breadth of expertise point of view. So current trends, can we fix it all? Well, to some degree, yeah. So what's happening now is that the tools that we are working on these days offer more capabilities, and they quite often run on the cloud. And this leads to a good amount of simplification of the whole data engineering stack. Many different parts of technology, many different areas in technologies do this. There are many different individual technology bits that follow this trend. So, for example, Informatica can now no longer just run the basic on-premise on-premise ETLs, but it can be used on big data. Same thing with Talent. There are new cloud solutions such as Fivetran that basically remove the need to have complex extractions from more common data sources. There is Stitch, does the same thing. SnapLogic, again, it's a UI-based tool, runs in the cloud, lets you put together ETL pipelines with no code, and on top of it can again run the traditional ETL workloads or ELT workloads as well as the big data stuff. Now, on the data lake side, we have things like HD Insights, which is a little bit older, but still brought an interesting innovation, which is suddenly you have cloud and you don't have to stand up your Hadoop clusters on premise. Databricks, Delta Lake do the same thing on Spark. And then on the data warehouse side, there is Redshift, Bigtable, BigQuery, Azure Synapse. But I'd like to talk a little bit more about Snowflake Data Cloud. And again, this could be just one of the many technologies that follow the same patterns of providing more capabilities and running on the cloud, leading to simplification. So how does the solution on Snowflake look like? And this is it. It looks very similar to our modern data warehousing solution, where we have the raw area and we can afford to load all the data with high velocity, high variety, high volumes without much trouble. It has the clean area where the raw data is slowly transformed into more and more curated data sets. It has a model data where we have the data warehouse in our third normal form or whatever particular methodology we choose to go for, and we have the analytics side, which exposes the data in a sense of data marts. which can be which can be materialized, or can be just virtual, depending on the approach. But still, like the work has to be done in order to set up the structures there. And then we have the work area for our data scientists that can hit pretty much any part of the solution. So in terms of functionality, it is very similar to the modern data warehousing. But what's different now is that it's all done within a single tool. So the expertise required to pull off a solution like this goes down dramatically, and it's all SQL. Snowflake is all SQL. It's very nice. There is it's almost a common denominator on anybody that works on the data engineering side. So knowing SQL is a very usual, very popular expertise to have. And then once we have it, we can all work together on using SQL in Snowflake Data Cloud. The other benefit is that the solution comes fully managed. This is the cloud part. So we don't have to take care of the infrastructure. We don't have to take care much even of the database administration and optimization. This is all done by the service that's capable to handle that part of the solution. The other benefit that we got from modern data warehousing, meaning that we don't need to model everything anymore, is still there, and it's there in the exact same way as it was before. We can just load all the data in, all the Twitter feeds, without regard on how the schemas look like, and simply store them in one simple solution, and then granting access to our data analysts or data scientists or anybody that may need it. Challenges, yes, of course. It is a bit less flexible. For example, Databricks would allow you to bring in your own jars, write quite sophisticated Java code that will run within the solution. Snowflake doesn't do that yet, but as we see in the overall trends, this is where the whole data engineering is going. These kind of features are becoming available, and for example, Snowflake is coming up with Snowpark, which is basically Spark on Snowflake, which allows you to do exactly what I just talked about. Allows you to bring in your own code to run where the data is. So fix is coming soon. Here is the scorecard. It looks a little bit better compared to traditional warehousing, and the major part is the expertise. Suddenly, we are all coming down to narrow again. It's a one system. It's all SQL. It's fairly simple to do. We don't need to have our Scala experts, our Python experts. We don't need to know how to stand up Hadoop clusters anymore. The expertise required is getting a little bit lower. In terms of effort, we are still gaining the benefits of what modern data warehousing brought, meaning we don't have to model everything. So the data pipeline design and development is still, it is still high, and it still needs to be done, but it's not very high as it was in traditional data warehousing. And the data architecture and data modeling are coming to be bit more on the medium side, as opposed to on the medium low as opposed to just medium. There are two other areas that solutions like this quite often help with, and then definitely the infrastructure part is getting a little bit lower on the effort side. This is because quite often these services run in the cloud, and the infrastructure is actually hidden from the service users. This is true of Snowflake. This is true of Fivetran, SnapLogic, anybody. Databricks, pretty much all the technologies I mentioned on the first page. Database administration and optimization on the Snowflake, this is getting low for sure. On other platforms, perhaps not as low, but still the other platforms, they are all moving in the same direction, trying to do I don't want to say the same thing, but trying to expand their capabilities so that they can handle more variety of workflows on the same platform without much of infrastructure, without much of an administration. Data governance I still have as red, because compared to to traditional data warehousing solution, we can still end up with data swamps if we are not careful. So overall, it is getting better. It's not a silver bullet. The effort is still there, and especially for traditional data analytics solutions, where the main portion or the main purpose of the exercise is to come up with your revenue by month reporting and orders by product and delivery by date. Those are still those still have to be done. But again, the data analytics and the data science workflows are enabled a little bit more without too much of an effort. So to conclude, well, is it still difficult? Absolutely, it's still difficult. It's still lots of work. We still have to go into the details. We have still have to have a good amount of expertise. We still have to understand the domain, understand the requirements, and understand the data. But it is getting easier thanks to the technologies that take care of concerns like infrastructure and the administrations, thanks to the technologies that let us not model every single piece of data, not touch it again. So yeah, this is this is the conclusion I think I'd like to make. The overall effort of the data engineering is moving in the right direction. So thank you for listening. I think we can jump into Q&A.
Excellent. Thank you very much, Milan. Super interesting. I would just like to remind our attendees that there will be a small form that they can fill in at when they leave this presentation, just to help us make them better in the future and keep generating great content for you guys. All right, so we do have a few questions that came up during the presentation. So let's start with a fairly high level one. So how can businesses accelerate their data strategy? Do you have any tips on that?
Now, the data strategy question is quite interesting because it really is high level. The answer from a technologist such as myself is really to have a look at the technologies, to see where they're going, and try to use as much of the newer ones as possible, so that the data strategy implementation gets a little bit gets a little bit faster. We are working on Snowflake. I would not want to advertise Snowflake too much, but there is the newer technologies that are out there. Many of them do offer the ways to accelerate the data strategy quite nicely.
Excellent. Another great question we have here. So what's your advice for a business looking to migrate from a traditional data warehouse that's on premises to a cloud-based data warehouse like Snowflake? What are some of the key trade-offs that they need to consider? You know, whether they should go lift and shift, refactor and modernize. Is the biggest consideration in there down to time and cost, or are there other factors that should be taken into account?
Yeah, this is an excellent question. There is the interesting part about the newer technologies like such as Snowflake is that to some degree they are a little bit less flexible than the old ones. The traditional data warehouses running on traditional OLTP databases would be able to handle certain workloads that Snowflake can't. So, for example, APIs, feeding APIs that query small bits and pieces of data. That would not be a very good use case for Snowflake, or anything related to OLTP, to transaction processing that requires frequent updates. Would not be good for Snowflake, but for a vast majority of the data analytics use cases, Snowflake would work quite well. Now, when we are talking about the trade-offs, I think this is the main one. Like one has to consider what's currently on premise and and how it's being used, and whether moving it to the cloud would cut off some of the possible workflows or some of the possible use cases or not. On the other hand, moving to Snowflake, moving to cloud would bring all the benefits that we talked about, meaning a little bit less work, a little bit less administration, simpler simpler maintenance, and then definitely much less of a struggle to keep the performance going, because it does bring the power of the cloud to the solution, where suddenly you can spin up many CPUs to run through huge amounts of data, doing large jobs in a very short of time, very short time. The other part of the question was lift and shift versus refactor and modernization, and then this really does depend on the business and what their what their purpose and what their main reason for migrating to the cloud is. Quite often we see customers that need this simply because of the scale. They can't run the current jobs, or that they're having they're getting to the limits of being able to run current jobs on premise, and they just need to go up to the cloud in order to use more of a horsepower that cloud solutions in general may provide. And for these, it may be the solution may be simply may be a simple lift and shift. Then there are companies that look at trying to expand the business and the data analysis capabilities, and then to go into more modern use cases. And then for those, perhaps the strategy there should be more of a more of a modernization, more of a bringing the data stack into into the area of modern data warehousing, where some of the data analytics capabilities are becoming a little bit easier.
Awesome. That makes a lot of sense. So I see that we are about to run out of time. So unfortunately, we won't have time to address the other questions. I would like, however, to let you know that our next webinar is already lined up. It's going to be a fireside chat with Mark Cunningham. So Mark is a pretty experienced person in the data industry. He's seen a lot when it comes to BI and analytics, going to be super interesting. So we're going to have a conversation with him. We will be open to questions. It's going to be very interactive. So we invite you to join us again on April 28th at the same time as this one. We'll be sending out, of course, invitations to everybody who was here today. And in the meantime, I would like to thank Milan very much for the super insightful presentation he's given us today. Really appreciated it. And yeah, I think that's it for us today. So join us next time. Next time, same time, I guess. And yeah, thank you very much for coming to this first Infostrux webinar. It's been awesome.
And thanks to Pierre as well. Thank you, everybody.